How to find a modified divisor D. Unfortunately, there's no formula for the modified divisor. Let's call that MD. Furthermore, there's usually more than one modified divisor that'll make Jefferson's method work. You can find one of these values using trial and error. So if you go back, we just finished this example, and it was kind of nice that they gave us a modified divisor number of 486. But most of the problems, you're actually going to have to figure that out on your own. You're going to have to kind of guess, and that's where the pain lies in these problems, I think. We begin with the fact that Jefferson's method, a modified divisor, is slightly less than the standard divisor. So for Jefferson, the modified divisor is less than the standard divisor. That's just useful for guessing. The standard divisor in that example was 500, and so 486 was the number that worked. Pick a number, D, that you think might work, carry out the calculations required by Jefferson's method, divide each group's population by D, round down to the nearest whole number, and find the sum of the whole numbers. With luck, the sum is the number of items to be apportioned. Otherwise, change the value of D, make it greater if the sum is too high and less if the sum is too low, and try again. In most cases, with 2 or 3 guesses, you'll find a modified divisor that works. So think about what we just did. We used this 486 number and did all of these calculations and got all of these numbers here. But if it didn't add up to 130, we can't do extras like we do with Hamilton's method. We would have to guess a new one of these numbers. So maybe if I had guessed 480 and it didn't add up to 130, then you're like, oh, well, maybe we try 490. Ooh, that didn't work either. Oh, let's try 485. Oh, that didn't work either. Let's try 486. It's really going to be a pain because you're going to have to do this over and over again. Now, it's not like that's hard. It's just kind of tedious. And so get your calculators ready and let's go. So for Jefferson's method, the modified divisor is less than the standard divisor. For Adams' method, the modified divisor is greater than the standard divisor. And Webster's method, the modified divisor is either less than or greater than the standard divisor. We don't know. Just have to guess until we figure it out. Upper quota violation is when the final apportionment is greater than the upper quota. And the lower quota violation is when the final apportionment is less than the lower quota. And what I mean by that, if you go back to this example, when we see this number of 8.97 right here, if you round down, that's 8. If you round up, that's 9. So that's the answer. It's either 8 or 9. It's either 8 or 9. And if it's anything else, it's going to be one of these violations. Example 4. We've got the same exact example. Consider the rapid transit service. We've got 130 buses that we need to apportion or distribute fairly amongst these 6 groups. We're using Adams' method. So Adams' method, we want a modified divisor that's greater than the standard divisor. We're going to use that to find that modified quotient, and we're going to round up. There will be no extras. So that's kind of a summary of what we need to do. In order to find the modified divisor, we need to think about the standard divisor. Remember, the standard divisor was the total population divided by the number of items. We already calculated this before. In this example, it was 65,000 divided by 130 buses, which was 500 people per bus, or 1 bus for every 500 people. And that's our standard divisor. So for the modified divisor, we have to pick a number that's bigger than 500. And it's just a guess. And so that's what we're going to do. Now write small because I'm going to use up pretty much all of the space that you have available here. We're going to guess a modified divisor that's bigger than 500. So let's guess 510. Remember what the word divisor means. Divisor means you're going to divide. So we're going to divide each of those group numbers by 510. And so I'm going to divide by 510, and when I divide 4360 by 510, I get 8.55. And divide, you're going to get 10.06, 13.88, 20.09, 30.46, 44.41. That's the modified quotient. The modified quotient was where we took the group population divided by the modified divisor. That's what we just found. All of those are the modified quotients, but we're rounding up because this is atoms to find the upper quotient. So round up, you get 9, 11, 14, 21, 31, 45. Round up. Don't round to the nearest. We round up with atoms. But you notice, if you add those numbers up, that's 131. That's too high. That's too big. That's not right. And we don't have the extras. We're not doing the extras. That's Hamilton's method. That's the only one with extras. We have to find a different number so that there are no extras. This number is too high. So we're going to need a bigger modified divisor. Think about it. If our number was too high, then we need to divide by an even bigger number than what we did before. Bigger than 510. And so that kind of tells me what to guess. All right, I need to guess a number that's bigger than 510. I'll draw an underline just to separate because I'm going to start again. I'm going to have a new modified divisor. Let's try 515. It's just a guess. But I'm going to divide by 515. I'm going to divide all those numbers by 515. So I get 8.47, 9.96, 13.75, 19.89, 30.17, 43.98. Those are the modified quotients. So we need to find the upper quotient because we're rounding up 9, 10, 14, 20, 31, and 44. Once again, we add those numbers together. We add them together. Those numbers added together give me 128. Oh, no. It's supposed to add up to 130. We're not doing the extras. It's got to make 130. This is too low. So if that's too low, then I'm going to use a smaller modified divisor. I need to divide by something that's smaller than 15, but still bigger than 510. So I'm narrowing it down at least. I know my answer is going to be between 510 and 515. So let's try something else. Maybe we try 512. See how tedious this is? It's not like it's hard. It's just who wants to keep doing this over and over again? But this is what we're doing. This is the method. Let's try 512. Modified quotients. I'm going to divide by 512. and I get those numbers. Adams method, we round up to find the upper quotients. Round up, 9, 11, 14, 21, 31, 45. $131, too high. Oh man, too high. Use a bigger modified divisor. Gross. Bigger than 512, but smaller than 515. Let's try 512.5. Yes, it can be a decimal. You could try 513. Maybe 513 would work as well. But I'm going to try 512.5. We're dividing to find those modified quotients. You can try 513 if you want, but this is just what I did. I divided all my group totals by 512.5 to get these modified quotients. Adams' method says we're going to round up to get the upper quotients. 9, 11, 14, 20, 31, 45, which finally adds up to 130. Just right. That's what we want. That's going to be our answer. This is the Adams method, so this is Adams apportionment. This would have been his answer, or his way of apportioning those 130 buses. No extras, but this is it. Number 5, same problem, different method. This time we're using Webster's method. It's still all the same numbers, but this time it's Webster's method. So Webster, we're going to have this modified divisor, but this time the modified divisor is either less than or greater than the standard divisor. We don't know. Either less than, greater than, not sure, don't know. We're going to find that modified quotient, but this time we round to the nearest. That makes sense to us anyway, because that's the way you round 99% of the time anyway. We're not rounding up all the time or down all the time. We're rounding to the nearest number. And again, there are no extras. I can't stress enough. The only one where there's extras is Hamilton's. The other 3 don't want any extras. So remember that standard divisor was the total population divided by the number of items. That was 500. That's kind of your reference point. That's how you know where to start. I need a modified divisor that's somewhere in that ballpark. But trick is we don't know at this point if it's less than or greater than or what. We just have to guess something. So maybe we guess 510. It's the same exact, but so was we did it with Jefferson's method and Adams' method and Webster's method. It might end up being the same numbers as the last one, but it might not. So you can start with 512.5 if you want to and see if that works, but it's not a guarantee that that's going to work.
How could it not? Like, why would it not be the same?
Because we're rounding differently. Right, right. We might round this one, up, and then the next one down. Right. So the rounding is the only thing that makes this different. but it is going to make it different. All right, good question. So we try 5, 10. We're dividing by that. We're dividing by 5, 10. That is the modified divisor. We divide these group numbers by 5, 10. And we already did exactly this calculation in that last problem. Should have gotten exactly these numbers. So yeah, here's the difference. These are your modified quotients, but we're not doing an upper quotient this time. We're doing the nearest. So this one's going up to 9. This one's going down to 10. Nearest. Nearest number is 14. Nearest number is 20. Nearest number is 30. Nearest number 44. Add those numbers up. Those add up to 127, which is too low. We need exactly 130. That's too low. So when it's too low, we use a smaller modified divisor. That seems backwards, but it makes sense because if that number is too low, then you need to divide by a smaller number. The divisor needs to be smaller. So smaller than 510. I don't know. It's kind of just a guessing game. Let's try 490. 490. We're dividing by that to find these modified quotients. Divide by 490. Divide each of these numbers by 490. And then Webster says to round to the nearest. Round to the nearest. 9, 10, 14, 21, 32, 46. 132. 132. Too high. Need a bigger modified divisor. Bigger than 490. Smaller than 510. We're narrowing it down. Okay? If you're a bad guesser, it's going to take you longer than it is somebody else. So hopefully you're a good guesser. Personally, I'm not a very good guesser. Let's try bigger than 490. Let's try 498. 498. The modified quotient, 8.76, 10.30. And then round to the nearest. 9, 10, 14, 21, 31, 45. 9, 10, 14, 21, 31, 45. 130. There we go. That's what we needed. Now again, there might be more than one different number that works. But once you find a number that works and adds up to the number that you need, that's your answer. We've got Webster's apportionment. This is how many buses each of these stations is going to get. Now, is that the same answer as what we got on the last one? Not quite. D has 21 here, but on the last one, when we did Adams, D only got 20. So it might be the same, it might be different, should be really, really close though, because of those upper and lower quotas. To summarize, we've got these 4 different methods, and the main difference is the rounding, but you also have Hamilton's is the only one that uses the standard divisor. Remember, the standard divisor was the total population divided by the number of items. That's kind of your starting point. All 3 of the others use a modified divisor. And in Jefferson's, the modified divisor is less than the standard divisor. Adams, the modified divisor is greater than the standard divisor, and Webster's might be less than or greater than the standard divisor. So it kind of gives a summary of what to do. Keep in mind where to round. Hamilton rounds down, Jefferson rounds down, Adams round up, and Webster round nearest. Otherwise, man, they're very, very similar to each other. The last page has some information about the Electoral College. It's kind of interesting to think that what we're studying is kind of similar to how they apportion the electors. And I think this map might be out of date, but you've surely seen this map before in your government class.